As a part of our real-time analytics, we learned the event stream in the previous class, right? Now, so as a part of the real-time analytics, we learned the event stream. Now it's time to learn about the event house. What do you think is a event house, Anna?
The event house stores real-time data.
Mhm.
It'll store in KQL database.
Okay, wonderful. Event house is a Microsoft Fabric real-time analytics, one of the module. It is designed to manage the store and manage the large volumes of time-based event data. See, basically, we understood the data is ingested through event stream. Then that has to be stored in some repository, some storage. Event house comes into picture, right? So event house is a module which is there as a part of the real-time analytics. Basically, event house is a module of a real-time analytics platform from a Microsoft, which is used to store and manage the large volumes of time-based event data in real-time analytics scenarios. Why am emphasizing on this, Parveen? Why am I saying time-based event data?
Live data and the current data we are dealing with.
Okay. So the reason is this is a storage module of time-based event data. If you want to store the other types of data, there are already so many systems, right? We have SQL Server, we have Lakehouse, Delta Table, all those, isn't it? Right? So we have the other storage systems within the fabric to store other types of data. You're getting my point, right? So here the idea is we needed a module to store the time-based event data. That is where event house comes into picture. See, please remember that. Since those modules are systems which are available earlier, they were not storing the time-based event data. As a part of the real-time analytics, they created one event house. So it is definitely a core part of real-time analytics solutions in Fabric. Okay, so that any organization which is dealing with the real-time processing, they can store and query the event data as arrives. Clear? Any questions here?
Yeah, I have a question. How long
Please.
the data can be saved here when amount of
That is a very good question. Okay. So usually what happens is the data as it arrives, right? It is not consumed as and when it arrives. Okay. So now it is definitely not like a long-term storage like a SQL Server, Lakehouse, and all. Okay. So there is a definitive period for which they can store the data. Post that, they persist the data in other modules like Lakehouse and all those things. That's a very good question, Malini, by the way. Okay. Got the answer?
so it will be moved to lake house after
So,
certain point of
see,
time.
yeah, whenever we talk about any of the real-time systems, it can be here, it can be Kafka, all those things, right? So, we need a storage to hold the data until it is consumed completely, okay, by all the consumers. So, what they would do is they would have a time period for which they can hold the data. You getting me right? It can be 7 days. It can be one day. It can be some days. And they'll store the data for that period. And then once that time period passes, that will be persisted. That will be pushed into the permanent storage. You got my point now, Malini?
Yeah, got it. Got it.
Now and again, we are emphasizing it is a real-time data storage. Real time means the data is flowing continuously. Okay. So where we are ingesting the data through event stream. We already discussed about event stream. Okay. So wherever we require a storage for a data which is ingested through event stream, that is where we use the event house. Now, if you want to work with the event house, you have to create a event house, right? There is no brainer there. To create a event house, to have a account. You have to have a Microsoft account where, guys, remember, capacity should support the real-time intelligence. Okay. While tenant is bought from an organization, within that you need to have a real-time capability. Then only you will be able to create a event house. When some organization is purchasing a fabric license, fabric license may have different modules. So one of the important thing what we discussed is a data warehouse, batch processing, and all those things. That is one kind of a module. And the second one is where some of the organizations are using the real-time analytics of a fabric. Wherever the capacity supports the real-time intelligence, there only you'll be able to create the event house. There is no confusion there, right, Anna? Okay. So basically, any organization which has a real-time capacity, only in that fabric account will be able to create a event house. Okay. Then once we create a event house, you can import the data from various places. We'll anyway discuss that. Okay. Now, what happens is, I already told you as a part of the initial overview, KQL database is tied to the event house. Okay. So whenever you create a event house, by default, KQL database created automatically. Because without KQL database, event house is nothing, right? Whenever you create an event house, KQL database is created. Okay. So event house can contain multiple KQL databases where you can manage the data using tables, functions, views, and more. Okay. Where are we now, Malini? Yeah, go ahead.
Event house.
Event
We're
house.
discussing on the event house here.
As a part of what?
Real-time analytics, Microsoft.
Absolutely, yeah. So we are discussing the event house as a part of the real-time analytics. Analytics are real-time intelligence platform within the fabric. You created a event house. Okay, all of you are wonderful guys. You created a event house. So what will you do after creating the event house? Muthuminal, what will you do?
We can analyze the data.
We can analyze the data. Before we analyze the data, what will we do, Anna?
So we can query and transform the data.
Load
Okay.
the data.
Yeah. Without the data, how will you query, Anna? Right? We need to load the data. We need to ingest the data, right? So with respect to that, some different aspects. Okay. So first we ingest the data, and we can also create some of the database shortcuts. We can also have some enablement of a one lake. Okay. So you created the event house. You should know how do you work with that. Okay. One of the very important thing to work with that, as Parveen said, you have to load the data. You have to ingest the data. Apart from that, you can create the shortcuts. You can also enable the one lake availability. Okay. Let us discuss them one by one. So as I already said, the moment you create a event house, by default, one of the KQL database is created. Now, as a part of different projects, you would have created multiple KQL databases. So instead of pulling the data from other KQL databases, you can create the database shortcuts to existing KQL databases in other event houses or data explorer databases. So what is the use? They almost work like you are, as a user perspective, all you have to do is you have to point to that external KQL database. No need to really worry too much of bringing the data, ingesting the data. It almost works like you are querying the data from external database as if the data was stored locally in your event house. Okay. So as a part of the organization, you have to use the data from other databases, other systems. Okay. If you don't have a shortcuts, it is a big headache. Okay. That is solved by the database shortcuts. Then one more very important aspect is one lake availability. Let me ask a question to Parveen. How one lake and event house are related? How are they related? Is event house part of the one lake? How are they related?
Yeah, event house is a part of the one lake. All the data will be stored in the one lake only, sir, in order to avoid the data duplications.
No, only in this case. Okay. What you said is right for all the other things. But in this case, this is a different data store. Okay, you got it right, Parveen? Okay.
Okay, sir.
Only in this case. That is the reason I am just emphasizing it. Okay, you can reconfirm that. Okay. So because this is a different data store, what we can do is, see, rest everything is boiling down to one lake, then Parquet files. But in this case, it's a database for a event data, right? So what we can do is, even though it is a different data store, we can enable the one lake availability for KQL databases or tables, so that the data which is there in the KQL databases is also available for other systems, Power BI, Warehouse, Lakehouse, other Fabric services. You got it, Anna?
Yes,
Okay.
sir.
We are making the data in a KQL database available to other systems through one lake. Okay, you got it? Fine. Any questions here? So,
One more, please repeat it, sir.
so see, as I said, now KQL database is not directly a part of one lake. Now, the data which is there in the KQL databases may be required for other services, right?
Mhm.
All other services are thinking one lake is their common storage.
Okay.
Now, if they want to access the data in KQL database, what they should do? That is where we can enable one lake availability for individual KQL databases, so that other services can access the data of KQL databases as well. Okay, got it, Parveen, now?
Okay, sir.
Okay, so
But,
yeah,
but will that be live streaming or will that be static data?
I mean, that will be kind of a static, because the data is already stored here, right? Ideally, it is a static, but if some system wants to access it as and when it is coming, it can be continuous also. Are you able to visualize what I'm saying, Malini? See, let us say data is there in the KQL database, which is a part of the event house. The data is getting ingested as in from the event stream. The data is coming and stored in KQL database. Now, let us say Power BI is accessing the data. After some time, it becomes a static. But if the data, as and when the data is coming to KQL database, that is being accessed by the Power BI, it can be continuous also. It can be real time also.
Okay, these rules are set by the organization or?
No. It all depends on the project.
Okay.
Now, a organization will be multiple projects, right? First of all, the Power BI is a BI project, right? This is KQL database is a part of the real-time project. Somebody in the organization has to say, okay, so we want a real-time dashboards for a particular project. For that, we have to integrate this and this. They have to take a call.
So this is done by data engineers or by analytics?
See, the decision is taken by the architect. Okay.
Okay.
So otherwise, the data engineer will in a way implement whatever the architects decide. Okay. So architect has to decide which system has to be connected to which system based on the requirement. That requirement will be coming from the business or the guys in the management.
Okay.
Okay. So the next one important is the data ingestion. So we can ingest the data into the event house from local files, from Azure storage, from Amazon S3 buckets, and also, as we have already discussed, we can ingest the data into the event house from Azure Event Hubs, Fabric Event Stream, Real-Time Hub. We can also ingest the data into the event house from a one lake, data factory, copy, or data flows, which I already discussed. And also, all of this are mostly in-house, means mostly Fabric and Azure related. So we can also ingest the data from external sources through Apache Kafka, Confluent Cloud Kafka, Flink, and we already discussed messaging, queuing, telemetry, transport. Amazon Kinesis is one of the module which deals with the real-time data, and also Google Cloud Sub or Pub, okay, publication, right? So we can also get the data from other connectors. Again, depends on the project, from where you have to ingest the data. Okay, wonderful. We discussed, we understood, we created the event house. Once we created the event house, we can KQL databases provisioned by default. Then to work with the event house, we have to be aware there is a shortcut, and also we can enable the one lake availability. And in order to work, in order to really start analyzing, we have to ingest the data. We have to load the data. Okay. Basically, I would say we have to ingest the data. Okay. So this is the anyway. We'll look at this as a part of the hands-on. Okay. So we can get the data from all these local files, one lake, event stream, and all. Okay. We have ingested the data. Right, Malini? What will you do after ingesting the data into the event house, Malini?
Either we'll create the destination or transform the data.
Okay, destination. Okay, that's good. Okay, anything else from anyone? What will you do after ingesting the data?
So we'll start querying.
We'll start querying. We'll start analyzing, right? So we'll query the data. Okay, after ingesting, we need to analyze. In order to analyze, you have to query the data. Okay, so to query the data, you have something called KQL. Okay, so in order to query the KQL database, we have KQL, Kusto query language. Or we can also query the data in event house by TSQL, T-SQL, that is transaction SQL, which we use as a part of the SQL server. Okay, we can query the data in a KQL database by using a KQL or T-SQL by or basically in. We write the code in KQL query sets, which we already discussed as a part of the introduction class. Okay, so as I said, in a way, KQL query set is a place we can write the queries. In a way, it is an IDE way for the KQL database. Okay, so when you create a KQL database, KQL query set is also created. Okay, we ingested the data. We want to analyze the data. In order to analyze the data, we have to query the data. To query the data, we use KQL or T-SQL. Where do you write the queries? In a KQL query set. In a KQL query set. So KQL is much more simpler than T-SQL. Okay, KQL uses a pipeline approach. Okay, pipeline approach. Those who are familiar with the Linux command, right? One of the famous, very widely used command is a pipe command. Okay, where we load the pipe the results of one command as an input to another command. Like let us say something EF. Okay. So I'll pipe it and I'll try to find something out of it. Okay, grep something. Okay, so pipe is one of the frequently used command. Okay, so KQL uses a pipeline approach where data flows from one operation to the next using the pipe character. Right? It's like you are funneling the result of one command or one script to another. Okay, so like you start with the full table and go forward. Anyway, we'll take the example by using the operator, filter, sorts. Okay, so what happens is that operator, filters, or sorts will summarize or do some operations on the data before you pass it to the next step. We'll see that. Okay, obviously, whenever funneling the result of one operation to another, and when you are using the operators and filters, order of operators is also important. As I already said, works on the output of each step, works on the output of the previous one. So let us take an example here. Taxi trip is a table. Okay, and then when I say taxi trips, it is getting the results of all the rows of a table. The result of that is funneled to this particular command. What are we doing in this command? Anna, what are we doing this as a part of this command?
So we are filtering for the fair amount which is greater than 20.
Excellent. Okay, so now this will produce some results, right? This result is funneled to this. Malini, what are we doing here in this case?
We're looking for trip ID and pick up date time based on the fare amount, which is greater than 20.
So here, this is the, let us say you have 100 rows. Okay, all the 100 rows are funneled into this. Okay, and the only 20 rows will qualify this. These 20 rows are projected here. Within that, project means it's kind of a selecting. We are selecting some columns. And within that, this will be funneled to this result. We are taking only 10 rows. Again, some of the Linux-like commands are used here. Take 10 means it's selecting only limiting 10 rows like that. You guys got? those who are really used to SQL, they'll feel a SQL is good and all those things. Somebody who is not used to SQL, this is like a very easy, very intuitive. Okay, you guys got it now? How the KQL works,
Yes, sir.
right? Malini, Anna, Muthuminal,
Yes, sir.
got it? Okay.
Yeah.
So just to dwell some more deep into this, understand a bit more. Okay, the simplest query consists of a table name. It will display the number of records. Okay, so in order to display the results or retrieve the sample of the data from a large table, we use the take operator. Okay, anyway, we'll discuss it in some of the important aspects as a part of the hands-on. Okay, but I'm just taking you through some of the aspects. Okay, we can aggregate the data also. See here by using the KQL, and as we already discussed, you write all the KQL queries in KQL query set. It will provide a workspace to run and manage the queries against the which queries, either KQL queries or TSQL queries against the KQL databases. Okay, so one important thing is KQL query set also allows you to save the queries, organize the multiple query types, and also share the queries with others for collaboration. Okay, that way if multiple people are there in the team, then you can do that also. Okay, so the KQL query set also supports TSQL queries, which I already told you, allowing you to use the TSQL syntax alongside the KQL for data analysis. Okay, that also can be done. And one more thing which is becoming as usual in any of the Microsoft related products is you can also use the Copilot to assist with the queries. Okay, so as you know, Copilot is one of the AI based tool which can assist the people either in the content generation or a code generation. Okay, so what happens is now, like, you are assuming that you are trying to write a KQL query to do something, so you are stuck. Okay, so what you can do is you can ask Copilot to generate the KQL query. Okay, because it understands that, but only thing is that need to be enabled as a part of your project. So basically, if it is not enabled, if it is there, you can ask your administrator if we have a Copilot license along with this product. Okay, if he says yes, you can say, hey, can you enable it for me, so that my job will be easy for me. Okay, so basically you can also use the Copilot to assist with your queries. Now, when we talk about any queries, right, we have to use the queries effectively. How will you use the queries effectively? What will you do, Parveen?
I mean, do focus on the performance.
Absolutely. So we have to optimize the queries. So when we say optimization, why do we really need to worry about the optimization? Because if you don't optimize, the query may take more amount of time. Okay, and so if you optimize the data, it will be easy for you to reliably work with the growing data, because you would have written some query which will run for the current data, but as and when the data increases, if your queries are not optimized, it may start performing very bad. Okay, so in order to avoid those situations, you have to optimize your queries. Okay, so if you optimize your queries, the queries run faster by reducing the data scan. And also, with both of this, the resources are also used less. So that is the reason it is very important for you to optimize. But the question is, how do you optimize? Malini, how do you optimize your KQL queries? What are the different things you have to do?
I guess by introducing joins or optimizing with
Mhm.
better operations.
Okay. Yeah, go ahead.
So we need to introduce index.
Okay, that is one of the thing for within the databases to retrieve the data faster. Okay, that's good. Okay, let us understand some of the optimization techniques. Well, so like really recollect, as a part of the event house, we are mostly capturing the data as and when it is coming. Mostly it may contain the time series data, right? If the time series data is coming, we can adopt a time based filter. I know it is simple, but sometimes those simple things will not remember. Okay, so since it mostly you may have a time series data as a part of your event house, you adopted time-based filtering. Okay. Then one more thing is, instead of like randomly organizing your filters, the way you can do it is you can put the filters initially to eliminate the most of the data first according to your let us say you have sequence of filters, filter 1, filter 2, filter 3. So you sequence your filters in such a way that like you whichever the filter comes first, which will eliminate the more amount of data, use that filter first. Okay. And then feed that results to the filter 2. That way, what happens is instead of unnecessarily scanning, filtering more rows at the later point of time, you are saving lot of time here. So basically, what he says is think of it like a funnel. Okay. Start with the filter that removes the most rows, then apply more specific filters to the remaining data. So that way you save lot of time. Then one more important thing is when we talk about the databases, when you talk about the tables, you may have lot of columns. Those number of columns may not be needed for your analysis. So what you can do is you can select only the columns you need for the analysis. That also improves the performance. Okay. And one of the are actually couple of things which will tax to the performance are aggregations and joins. So you have to structure your aggregations and joins in such a way that you take less time. Okay. Some of the examples to do so, right? For example, in aggregations, okay, limit the results when exploring the data. That saves a lot of time. Your database or table may have lakhs and lakhs. Okay. Number of mention the smaller table first. When as a part of our when you join you can mention the smaller table first. So you would have a fair idea of which table is small, which table is big. Okay. So whenever the joining happens, KQL process the first table to match the second table. Okay. So what happens is when you start with the smaller table means the fewer rows are processed first. That way joins are more efficient. Okay. So these are some of the optimization techniques you have to bear it in mind. Now the last thing is you have materialized views and stored function. Any thought? Malini, what are materialized views?
Probably subset of the tables.
Okay. So when we say materialized views, right, they are pre-computed aggregations. So they are mainly used to improve the query performance in the KQL databases. Okay. So they may handle the data from IoT sensors, logs, or anything which will accumulate the data on a timely basis. So important thing is they are pre-computed. So as the name suggests, they are views. Okay. If you guys remember, tables are different from views. Okay. Views do not store the data. Okay. Views are the virtualized tables. Okay. So, and auto update the aggregation results as and when the new data arrives. So what happens is, let us say you have some 10,000 rows. Okay. And you have only 100 rows are coming. Okay. Again and again recalculate the mean and something, all the rows, that will consume lot of resources. Instead of that, so these results are combined with this result. Okay. That way, the amount of time taken to compute the results will be very, very minimal as compared to computing the aggregations with all the rows. So material exactly it works. There are two parts to it. Okay. The first part is materialized part. Okay. In materialized part, we already have a pre-computed aggregation result from the data that has already been processed. Then we have something called delta. Okay. Here, the new data that has arrived since the last background upgrade, that is the delta. Guys got it, right? So as I said, 10,000 rows, which is already there, 100 rows are delta, which has arrived after the update. Now, what happens is, whenever user queries, both this materials part and delta parts are combined to provide the fresh, up-to-date results. Okay. So while the background processor periodically moves the data from delta into the materialized part. Okay. Basically, in order to make sure that the data of delta is baked into the materialized part, the background processors are the ones which will move the data from delta into the materialized part, ensuring speed and real-time accuracy. Beautiful, right? Okay. If somebody would have not thought about it, if every time the query has to consider all the number of rows, that would have taken a lot of time every time. In order to avoid that, they have beautifully developed this process. You guys got it? Any questions, Parveen, on this?
No, sir.
Beautiful. I mean, are you guys able to appreciate this? What at all they're thinking, what at all they're doing, right? So there are so many aspects. This is kind of awesome. Okay. The last part of the class today is stored functions. Beauty here is the KQL has a ability to save a query as a function. Whenever you have a query which you are using repeatedly, then you can use that as a function. Okay. And further icing on the cake is you can also specify the parameters for a function. Okay. So that you can repeat the same function, same query with the variable values. Basically, as a part of the KQL, it will allow you to store the query as a, that function can be used multiple times instead of writing the query again and again. And also parameterization is also allowed as a part of that particular query. Okay. So like whenever you have a streaming data with multiple people writing the queries, if one person has written a query and the same query can be used from another person, you can use it. Why do you want to each member of a team need to write the queries repeatedly? Okay, he can save that as a stored function. That particular function can be used by other people also. Okay, that way if the same proper function which is query which is saved as a function is used with validations for multiple people, it will definitely reduce the errors. Okay, and there'll be calculations will be consistent. Wonderful. That is the end of today's class. That's all for now. Like and subscribe and turn on notifications for future videos. Thank you. As a part of our